For my final project, I made a violin using SolidWorks, and as you can see here, I have my name etched into the violin bridge. The violin is an organic structure, so it was very hard to model it using an engineering program. And the first problem I encountered was making the scroll. This took me quite some time to figure out, and my inspiration was Riemann sums, where you can use sections of small differences to estimate the length of a curve. And that's what I did. I sectioned the descending helix into multiple pieces and extruded them at different lengths to form a helix structure. It's not perfect, but I think it's a pretty decent representation of what the scroll should look like. For the body of the violin, I inserted a sketch picture and traced out the profile of the violin and then extruded it at 4 centimeters. I also used the shell function to create uniform thickness throughout the body. The sound post is then attached to one side of the shell. In the assembly, I attached motors to the tuning knob so it can rotate within the holes of the scroll. I did an FEA stress analysis on the tailpiece of the violin. The reason why I did this is because I once broke my violin when I was little because this part failed from me practicing too much. A stress of 1 pound is applied to the face at which the tailpiece attaches to the end piece, and the fixed surface is the surface attached to the pin. Overall, this was quite a challenging project. I learned a lot about what SolidWorks and CAD programs in general are capable of. Although there were many obstacles, I thoroughly enjoyed the planning and problem solving of the process. I also had the opportunity to understand the anatomy of my violin a little bit better and truly appreciate the craftsmanship that goes into making a violin.